In this video, we are going to do some more practice with the Normalcdf command and the InvNorm command. So it says, suppose a normal model describes the fuel efficiency of cars currently registered in Maryland. The mean is 24 miles per gallon with a standard deviation of 6 miles per gallon. So we have a normal model with a mean of 24 and a standard deviation of 6. And it says, what percent of cars get more than 35 miles per gallon? So because this problem is asking us for the percent, so what percent? I know that I'm going to use the Normalcdf command. Now, in the previous video, I was drawing the normal model and filling in all of the standard deviations. You don't have to do that. If you want to, as part of your work, you can, but it's definitely not a requirement. Because it's looking for normal, or for looking for a percent, I know I'm using Normalcdf. And it says, what's the percent that gets more than 35 miles per gallon? So that means that 35 would be my lower bound, and positive infinity would be the upper bound. Again, I'm just using that bunch of nines. This time the mean is 24, and the standard deviation is 6. And so putting that in your calculator, you're going to get 0.0334, which is about 3.3%. For part B, it says, what percent of all cars get less than 15 miles per gallon? Again, because it's asking me for a percent, and we're using the normal model, I know that I'm using the Normalcdf command. This time it asks for less than 15%, less than 15 miles per gallon. So I know that the lower bound is going to be negative infinity. So I'm going to enter negative 99999. Again, be sure to use the negative sign and not the subtraction sign in your calculator. If you use subtraction, your calculator is going to give you an error. So the lower bound is negative infinity, the upper bound is 15, the mean is 24, and the standard deviation is 6. And when you put this in your calculator, you'll get 0.0668. And this will give you about 6.7%. And then part C, what percent of all cars get between 20 and 30 miles per gallon? Same thing, it's asking for a percent. I'm using a normal model, so I know I'm going to use Normalcdf. This time the lower and upper bound are right in the problem. These are the nicest ones, because I know we're just going from 20 to 30, with a mean of 24 and a standard deviation of 6. And this will give you 0.58885, which rounded is 58.9%. So now, again, I just couldn't fit it all on one page. Still the same scenario. I'm talking about the fuel efficiency of cars in Maryland, and I'm applying a normal model. And for part D, it says, describe the fuel efficiency of the worst 20% of cars. Well, the worst 20% are going to be the lowest 20%, or the left side of the 20%. So regardless of which calculator you're using, the old one or the new one, you're going to enter 20% for InvNorm. And I know I'm using InvNorm because it's giving me a percent, and I'm looking for the value. So lower 20%, mean is 24, standard deviation of 6, and we're doing left. If you have the older calculator, you don't have to write left. And when you put this in, you will get 18.95. And remember that that is not a percent. That's a data value or a projected data value. So this is in miles per gallon. For part E, it says, what gas mileage represents the third quartile? So remember that the third quartile is the 75th percentile. So the third quartile, which is Q3, is the same as the 75th percentile. And that means the lower 75%. So again, regardless of which calculator you have, because we're talking about a left area, you don't have to change anything. You're just doing inverse norm. It's the left 75%, with a mean of 24 and a standard deviation of 6. And with this one, we will get 28.05 miles per gallon. For part F, it says, describe the fuel efficiency of the most efficient 5% of cars. So the most efficient cars then are going to have the best fuel efficiency. So now we're talking about a right side area. If you have the newer calculator, you can enter inverse norm with 5%. Remember to write this as a decimal, 0.05, with a mean of 24 and a standard deviation of 6, and you're going to choose right. And you will get 33.87 miles per gallon. So we know that the most efficient 5% of cars will have a fuel efficiency of 33.87 miles per gallon or better. If you have the older calculator, you're going to have to convert this to a left area, which means you're going to have to subtract that 5% from 100%, and you want to enter 95. And that's the left percent, and you'll get the same answer. For part G, it says, describe the fuel efficiency for the middle 60%. So if you have the newer calculator, you're going to enter 60% using 24 as the mean, 6% as the standard deviation, and then you're going to choose center. And that's going to give you the interval from 18.95 to 29.05 miles per gallon. But if you have the older, I keep clicking the wrong thing right before that. Okay, if you have the older calculator, you have to do a little work here, and I'm gonna draw a quick sketch before I start writing things out. So looking at the middle 60%. So if this is the middle 60%, I didn't mean to write 8, I meant to write 0. Let's try that again. All right, so this is the middle 60%. That means that I have 40% left over, which means 20% is going to be above this value here, and 20% is going to be below this value here. So to find this first lower value, the left area is 20%. So I'm going to enter inverse norm with 20. And you'll get that 18.95. To get the upper bound, it's a little bit trickier. we have to, the left percent, we have to add the 20% to the 60%, because it's going to be this entire area that's to the left of this value that we're looking for. So we're going to enter inverse norm with 80% to get the 29.05. And then you can write it as an interval. Okay, that's chapter 5. Please let me know if you have any questions.